Often, when we talk about the 2005 hurricane season, the first thing that comes to mind is Hurricane Katrina. Surprisingly, Hurricane Katrina was not the most intense storm of the 2005 season. That title belongs to Hurricane Wilma. Hurricane Wilma set several records, including the most intense storm, the smallest eye on record, and the most rainfall in a single day. Throughout this video, we are going to talk about some interesting facts about Hurricane Wilma. We're going to discuss the evolution of the hurricane, some of the key hydrometeorological data associated with the hurricane, and we're going to talk about the impacts that the hurricane had to the US and to other countries in the Caribbean and Mexico. The graphic here shows Hurricane Wilma's official hurricane track. But let's talk about her humble beginnings really fast. The National Hurricane Center was monitoring a low pressure system, which became more defined on October 14th. 4 days later, on October 18th, Wilma was officially a hurricane, and from there, she rapidly intensified. Literally the next day, October 19th, Hurricane Wilma set her records for low pressure and high winds. During this time, Wilma's eye was a mere 2 miles wide. The lowest pressure recorded on Hurricane Wilma was 882 MB. Remember, low pressure is indicative of strong hurricanes. Wilma made landfall on October 21st near Cozumel, Mexico. She hit Mexico again on the 22nd, weakened over the Gulf of Mexico for a day, but picked up steam yet again and had landfall on October 23rd in Florida as a Category 3 hurricane. Wilma rapidly continued up the Atlantic coast, and by late October 25th, her remnants were gone. Hurricane data is collected in 3 main ways: satellites, from ground-based and aerial radar, and from gauges on the ground. So what kind of data are we looking at? What are the parameters that we want to check out for Hurricane Wilma? How about rainfall quantity, rainfall intensity, wind speed, air pressure, radar reflectivity, and aerial imagery? Rainfall quantity, or rainfall accumulation, is a critical piece of data which helps to describe the intensity of a hurricane. This data is collected in all 3 ways that we discussed: satellite, radar, and ground-based gauges. One satellite-based product is the tropical rainfall potential, which predicts how much rain might fall prior to landfall. Prior to landfall in Mexico, the estimated rainfall totals were 300 to 500 millimeters. Prior to landfall in Florida, it was estimated to be 100 to 200 millimeters. Gauge data, however, told a much different story. The Mexican gauge on the Isle of Mujeres collected around 1,600 millimeters of rain in a 24-hour period, far exceeding the predictions. In Florida, the National Weather Service showed a 3-day rainfall maximum of 200 millimeters, but at the Kennedy Space Center, it was 300 millimeters. Satellite data showed a maximum of 400 millimeters off the coast of Mexico, much less than the gauge data. Radar reflectivity helps us figure out the rate at which rain is falling, or the rainfall intensity. This helps to predict things like flooding. As Wilma landed in Mexico, Mexican-based radar showed her rainfall rate was between 51 and 127 millimeters per hour. But satellite data from a similar time period showed less intensity. Radar reflectivity indicates intensity. As Wilma made landfall in Florida, this image shows the radar reflectivity. The red spiral bands outside the eye are areas of intense rainfall. An interesting study from Florida about citrus bacteria developed a cumulative rainfall intensity map using the kriging method from 220 GPS locations across Florida. It showed greater than 17 millimeters per hour, which was similar to the satellite-based data. Wind speed and air pressure from the tropical cyclone report for Hurricane Wilma are shown here. Note the rapid drop in pressure at the same time there's a rapid rise in wind speed. This rapid intensification has resulted in many scientific studies. Satellite-based aerial imagery helps us paint a picture of what's going on when major weather events are occurring. This satellite-based product shows the water vapor and the warm sea level temperatures during Hurricane Wilma. Hurricane Wilma caused significant impacts to U.S., Mexico, and the Caribbean. In Florida alone, over 3.5 million customers were without power. The impacts were primarily felt in the middle to lower income residents, particularly in Mexico. Thanks for checking out my presentation on Hurricane Wilma. These are some of the references that I used for the presentation.